I wanted to show you how to do a couple of these problems just in case you missed class Wednesday or Thursday. Now, on this very first problem that you have to work on today's assignment, this one is treating HClO3 as a strong acid. Sometimes you will see this one listed as one of the strong acids. So if you don't know your strong acids at this point, you got to get those down by the next time that I see you, which will be Monday if you're in third period, or Tuesday if you're in sixth period. So we've got HCl, HBr, HI, I know they're on the board behind me, HNO3, HClO4, and H2SO4. HClO3 is mentioned as a strong acid in some text. So if you happen to run across HClO3, which I will tell you in my experience, I haven't seen it often, but occasionally a writer will use HClO3 and just an assumption that it's one of the strong acids. I want you to memorize these 6, okay? Those are your 6 strong acids. This one should have a Ka value given to us, but since they don't, we're going to treat it just like it's a strong acid. And so as a strong acid, then all of it, 100% of it, is going to dissociate or is going to ionize in water. So that means that if your original amount was 0.389 molarity, then now your hydronium ion concentration is 0.389 molarity. Okay, so to find your pH, we're just simply going to take the negative log of 0.389. I'm sorry, I think I said that wrong a few minutes ago. And that's going to give us our pH. And so our pH is equal to somewhere around 1 something. So negative log of 0.389. And that is under 1, so we're going to call that 0.41. Sig fig wise, we need one more 0. There we go. There's our pH for the strong acid. Now, because you are going to do the rest of these, if you look at HClO4, it's a strong acid. HNO3 is a strong acid. HCl is a strong acid. HCl is a strong acid. They're all in the group. And it also says up here at the top, strong acid calculations. When you get down to the weak acid calculations, this is like the problems that we did on our lecture guide. Let's see, we're talking numbers, sample exercises 8 and 9 on your lecture guide. I'm going to do one of these for you just to refresh your memory on this. So really all you have to do on your weak acid calculation is remember to go ahead and break this apart so you have an equation. And your Ka expression is equal to hydronium times the lauric acid. That would be that's the lactic acid, so that'd be lactate. Probably heard of that before, especially if you're lactose intolerant. H5O3 minus over your acid, HC3H5O3. I want to see your expression written on all of your weak acid species. So you should have this written, you should have this written, okay? All right, and then we're going to plug in our original concentration that's going to go on the bottom. First of all, are these two numbers at least 1,000 times different from each other? Okay. So are they at least 1,000 times different? And I would say, yeah, they're at least 1,000 times different. So I'm just going to do some plug in real quick. All right. On top, we would assume each one of those is an x. So I'm going to call that x squared. And on the bottom, we're going to put in our original concentration for the acid. And then that's equal to your Ka value, 8.3 times 10 to the negative 4th. Okay, multiply across your equal sign, solve for x. So I'm going to do that one real quickly. Got 8.3 times 10 to the negative fourth times 0.25. And then we need to take the square root of that. So second square root. All right, and so the X value, which is your hydrogen ion concentration, is 0.0144. And then we want to take the negative log of that to get pH. And I know there's not a lot of room on that part, but I think you can handle it. Negative log of that number, enter. Okay, and so the pH on this first one is 1.84. Okay, there's my final answer. Whoops, sorry, I guess you couldn't say that. So there we go. So we took the negative log of that number, gave us the pH, and that's supposed to be an equal sign right there. Okay, and so our pH is 1.84. And so that's how you're going to do any of the weak acid calculations when your job is to find the pH. Just set up an equilibrium expression. Now, there is a table of weak acids and weak bases in your textbook. Go over and grab you a textbook, and you're simply going to list these in order from weakest to strongest using your Ka values on the next one. Okay. If you have the pH on number 6, you can work backwards and calculate the Ka. Remember, if you know hydronium, then it's going to be the same as your anion. Those two things would be equal, and so you could plug those into your equilibrium expression like that, and they're giving you the concentration, which will be your bottom number. So work backwards. If you weren't here yesterday or you weren't here Wednesday, then all you have to do to take care of this is you're going to take the anti-log of a negative pH to get to your hydrogen ion concentration. And it's real easy to do with your calculator. There are actually about 3 different ways you can do this. Anti-log can be found by doing second log, and see how you have the little 10 cursor, and we're going to put in a negative 2.77, and then notice that I get, that is the hydrogen ion concentration. That's one way to get it. Another way is just do 10 upper caret negative 2.77, hit enter. Oh, same number. Or you could put this in incorrect scientific notation. 1 times 10 to the negative 2.77, hit enter, and look, you get the same number. So there's 3 ways to do the same thing. That's basically taking the anti-log of your negative pH. So once you have your H positive concentration, you also know your anion concentration. We're going to call that a 7 right there. Okay, and so just remember that the H positive and the anion concentration are the same value. All right, let's see. Let's look at any of these other things that you've got. And you need to use, on number 7, it looks like you need to use a table of Ka values. There is a table of Ka values in your book. You can definitely find one. There's also one in your lecture guide. Let's see if those should be on there. Yeah, nitrous acid is there. So 4.0 times 10 to the negative fourth for nitrous acid, and acetic acid is 1.8 times 10 to the negative fifth. That one's there. So it's in your lecture guide. There's also another one in your textbook. Okay, let's look and see if there's anything else that might throw you for a loop. Okay, on the next one it says a solution with a total, this is number 8, total volume of 250 milliliters is prepared by diluting 20 milliliters of glacial acetic acid with water. Calculate the H plus and the pH. Assume that glacial acetic acid is pure liquid acetic acid with the density of 1.05 grams per mil. So it looks like you need to do some conversions. If you know density is mass divided by volume, then you can just simply take 1.05 equals your mass, and your original volume of your glacial acetic acid is 20 mils. And so your mass would be equal to 20 times 1.05. So 21 grams. And we can't keep that in grams. We've got to change that to moles. So let's real quickly change that to moles. Acetic acid is HC2H3O2. So I'm going to get a real quick molar mass for that. I've got 4 hydrogens, so 4.04 plus 2 oxygens, which would be 32, and 2 carbons, so 24.02. So the molar mass should be 60.06 grams in 1 mole. Okay, and so 21 divided by 60.06 gives us 0.34, I'm going to call that 0.350 moles. Now, why am I doing all that? Because we actually need the molarity of this acid. We're diluting it with water, and it says a solution with a total volume of 250 milliliters is prepared by diluting this with water. So our total volume when we get through putting water in is 250 mils. So if we divide this by 0.250 liters, which is the same thing as 250 mils, then we'll have the molarity of our acetic acid. And then you can go from there. So you just had a little conversion problem on that one. All right, so divide by 0.250, and we get the molarity is 1.4 molarity. So that's your original concentration of your acetic acid. And so since it's a weak acid, you need to write your Ka expression and go from there. And if you look at acetic acid, its Ka value is 1.8 times 10 to the negative 5th, because you just got through looking that one up if you've already worked number 7. All right. Just kind of sliding down through here, see if there's anything else that's kind of weird that you might have to work. That one looks pretty normal. Percent dissociation, that was like the problem we worked in class on your lecture guide. That would be like sample exercise 9. Remember, percent dissociation is just simply part divided by the whole times 100. Okay, so you've got to actually find your X, and then you can plug that in to find your percent dissociation. Okay, when you have a mixture of an acid, it's all about the strong one. And in these two, this acid mixture, they're both strong. So you're just going to combine them. Okay, you got 100 mils of this, and you've got that molarity. So find out how many millimoles you have of each one, add them together. Since both of these are strong acids, so if I take 100 times 0.1, I'm going to have 10 millimoles of the nitric acid, and then 200 times, let's keep hitting the wrong key, 0.3, I'm going to have 60 millimoles of the hydrochloric, add them together, that's 70 millimoles. You guys can't see that, I'm sorry. Wasn't paying attention to you. Okay, so I'm just multiplied the 100 times the 0.1. I got 10 millimoles. 200 times 0.3 is 60 millimoles. That's a total of 70 millimoles of strong acid, which would be 70 millimoles of hydrogen ions, since both of them are strong. All right, and then the total volume, because we need concentration, is 100 plus 200, so they'd be divided by 300 milliliters. So now our concentration is 70 divided by 300, which is 0.2333333. That's your concentration of your hydrogen ions. So 0.233 molarity of H+. Now you can calculate your pH from there, okay? So on number 14, you have both of these are strong acids. Just do that exactly like I did number 13. All right, continuing on. When you have weak acids, then you really aren't going to have enough of the weaker acid, especially if there's a significant degree of weakness. So just use the strongest of the two. Like for instance, the Ka value of this one is times 10 to the negative 5th, and that one's times 10 to the negative 10th. that's not going to effectively change your pH. I mean, this one won't. So it's just really going to be what's the pH of this acid. Now, if you wanted to figure out the hydrogen ion concentration of each one and add them together and see if it affects the pH, you can, but honestly, find the pH of this acid since it's so much stronger than this one. And you're looking at a -5 to -10, so that's 5, 6, 7, 8, 9, 10. You're 1, 2, 3, 4, 5. You're at how many times different? A 1 with 5 zeros? 100,000 times stronger is basically what you're looking at. So that means that that's not acetic acid. That acid is 100,000 times stronger than hydrocyanic acid. So you're not going to see a difference in the pH when you look at sig figs. Okay, just deal with the stronger of the two in that situation. All right, and the next one is calculate the pH of a solution that contains HF and this. Also calculate this at equilibrium. Okay, so let's double check the Ka values for those and see if that's going to make a difference for you. HF, it's a 7.2 times 10 to the -4th, and phenol is 1.6 times 10 to the -10th. So that is not, I would calculate the pH based on that acid, and its Ka value again was 7.2 times 10 to the -4th. So you can calculate the pH strictly based on that. Now, how are you going to figure out the concentration of this? Well, when you figure out your H value from the HF, then that would also be the H value for that. And so you could actually do a little plug and chug. You know that you would, let's just write this out. Your Ka for this expression would be equal to H positive times OC6H5 negative over HOC6H5. So you know, you look up your Ka value, you have that. You have this concentration, you have this concentration. This would be your value you don't know. Where do you get the hydrogen ion concentration? You get it from whatever it is that you calculate here, okay? And so you just plug all your known pieces in and solve for your unknown piece on that one. All right, and then the last part of this worksheet is a polyprotic acid, and so you're going to write out the reactions for a triprotic acid. Let me show you how to write out reactions for a triprotic acid. I don't want to do the one that's given to you because I want you to have practice on it. So let's say I have this acid, H3PO4. So if I write out each reaction that happens, I'm only breaking off one hydrogen at a time. Okay, so there comes off one hydrogen and I have H2PO4 negative. Then I'm going to take that because it can still lose another hydrogen, and this would be the second ionization reaction. And so that would be HPO4 to negative. Okay, and notice I still have an acid. Actually, it's an amphoteric species. It has an H, it has a negative charge, but it still can act as an acid. So HPO4 2 minus breaks down into hydrogen plus the PO4 3 minus. And so that's what they're asking you to do on number 17. They want you to write out the stepwise reactions for citric acid. So you've got, notice, 3 hydrogens on that. It's a triprotic acid. All right, number 18, calculate the pH and concentrations of all species for 0.35 molarity H3BO3 given the following. So they give you a Ka value for each one of those. So you need to break this puppy apart just like you would do on number 17. And then your first ionization is your strongest. Notice your Ka value. Once you have your H plus, you would actually use that to figure out your amount of each one of those. So I'm going to let you contemplate that one and see what you can come up with on that. But I want to see all three of your reactions written out for H3BO3, and I want to see your Ka expressions. And I definitely want to see the first one done. And if you're like struggling on what to do with the second one and the third one, that's fine. We can talk about that in class the next time I'm with you, which will be Monday or Tuesday. Don't forget to study your strong acids and strong bases. You will have a quiz on those on Monday, if I see you Monday, or Tuesday, if I see you Tuesday. All right. Do your homework. Get it done. Bye.